Hello, my beautiful students. Today we'll be talking about something called trigonometric ratios, which we use something called trigonometry to help us solve for the sides of a right triangle. Now, I know that I've technically taught you one technique you can use if you know two sides of a right triangle. This formula will help you to find a third side. Do you guys remember that? Well, of course you remember because you guys are brilliant. But anyway, so the formula I've taught you that will allow you to solve for one side of a right triangle if you know two of the sides would be the Pythagorean theorem. So the Pythagorean theorem is really helpful if you know two of the sides of your right triangle. But sometimes in life we do not know two sides of a right triangle. We only know one side of a right triangle. Okay, so there are some ratios that we'll be talking about that relates to an angle in the right triangle and two of the sides. And using these ratios, it will help you to solve for the sides of a right triangle, especially when you're only given one side of a right triangle. So you can only use the ratios I'm about to teach you with a right triangle. Okay, don't try doing this with any other kind of triangle. Technically, when you get to a higher level math class, you'll learn about a more complete formula that you can use with any triangle. But for now, we're going to stick to these ratios that you can use with only right triangles. So be careful. Okay, so trigonometric ratios. Okay, so there are three ratios that we're going to talk about, which are called the sine, cosine, and tangent. Okay, sine, cosine, and tangent will compare different sides of the right triangle, which will help you to either solve for a missing side of your right triangle or a missing angle. Okay, so this is always really helpful if you either only have one angle in your right triangle, one side of your right triangle, or if you only know that there's a right angle in your right triangle. So if you're missing the other two angles, these formulas will also allow you to solve for a missing angle in your right triangle. So they're really helpful for finding the sides and angles of a right triangle. Okay, so before we get started, these ratios pertain to different sides of the triangle, and they pertain to a location in terms of an angle. So we're going to start from an angle, and these sides will pertain to how do they relate to this angle. Okay? So when I say the opposite side, well, that will be the side that's directly across from the angle that you're either given or trying to solve for in your right triangle. Okay, the side adjacent. Adjacent means next to. Now, technically, if you have an angle, there are two sides that are right next to it. The adjacent side is the side that will be next to the angle that we're either solving for or using to help us solve for a side. Okay, the adjacent side is the side next to the angle. That is not the hypotenuse. So, if you see an angle is kind of mirrored by the hypotenuse and a side right next to it. So the side next to it that's not the hypotenuse is called the adjacent. And then your hypotenuse, you guys should know all about this. This is the side directly across from the right angle. Okay, now we have three ratios: sine, cosine, and tangent. Sine will compare the opposite side to the angle that we're either given or trying to solve for over the hypotenuse. So it'll be the side opposite, the side that's directly across from the angle, over the hypotenuse, which is the side directly across from the right angle. Cosine is going to be the ratio of the adjacent side to the hypotenuse. So the adjacent side is the side next to the angle. That is not the hypotenuse. And then the hypotenuse is the side directly across from the right angle. Okay, and then tangent is going to be the ratio of the opposite side in comparison to the angle you're starting with and the adjacent side. So again, the opposite side is the side directly across from your angle. The adjacent side is the side next to the angle that is not the hypotenuse. Okay, and I have this nifty little acronym to help you remember the ratios of sine, cosine, and tangent. So sine, S, is the opposite of the hypotenuse, so sa. Sine is the opposite over the hypotenuse. Cosine is the adjacent side of the hypotenuse. And then TOA, that's my favorite one, TOA, sounds cool. TOA, tangent, is the opposite side over the adjacent. So it's SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Okay, so hopefully that acronym will kind of help you remember the ratio. So again, sine, opposite over hypotenuse, saw. Cosine, adjacent over hypotenuse. Tangent is opposite over adjacent. So again, it's just a little acronym to kind of help you remember the ratio. So don't forget it. Okay, well, let's get started on example 1. Before we start on example 1, I want to go over some tips to help you while you're solving. So one of those tips is you never start from the angle that's the right angle. So when we talk about like the opposite side and the adjacent side, that's coming from an angle that is not the right angle. So you can never start from the right angle. It doesn't work. Okay, also when you have the ratio, since ratios are fractions, make sure if you can reduce down your ratio, you do. So make sure you write your fraction in its most simplified form. You should always write your fractions in their most simplified form. Okay, so example 1 is going to relate to this triangle. Example 2 will relate to this triangle. So go ahead and copy down the triangle. Okay, so we're going to just be practicing writing our ratios out. Okay, we're not solving anything yet. We're just practicing using each of these trigonometric ratios and setting up the problem, because in our next problems, we'll actually be using the ratios to solve for missing sides and eventually missing angles in the triangle. So all that example 1 and 2 are doing, which I need to go back because now you can see all the answers. All example 1 and 2 are doing, sorry guys. All we're doing is we're practicing writing the ratios. Okay, that's all we're doing. Okay, so let's get started on example 1. So we're always going to start from an angle on the triangle. Okay, sometimes we'll be using this angle to help us solve for a side. Sometimes we'll be using this trigonometric ratio to help us solve for the angle. So sometimes we'll know the value of the angle, sometimes it'll be unknown. Okay, so we're going to start from angle T when we do each ratio. Okay, now I have the little acronym here to help you. SOHCAHTOA, sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Okay, now before I get started, if you see sine, cosine, and tangent, these are the abbreviated versions. Remember, mathematicians are lazy. Okay, SIN, it is sine. Technically, it looks like this. Sine. Okay, so it'll be SIN will be sine, COS will be cosine, and TAN will be tangent. Okay, please do not call them the sin, the cos, and the tan. Okay, first of all, we don't sin in math, so you shouldn't call anything a sin. But anyways, just please call them the right thing. So it's still sine, cosine, tangent. Please do not say sin, cos, and tan. It'll drive me up a wall. But anyway, so we're going to start from angle T. Before I get started, since this pertains to the side opposite, adjacent, and hypotenuse, to get all these ratios, I like to go ahead and label which side of the triangle is the opposite side, the adjacent, and the hypotenuse. Okay, so we're starting from angle T. Now the side opposite of angle T is the side directly across from angle T. So the side, like if you see angle T is like kind of opening up toward this side. Okay, so the side opposite of it is the side directly across. So 8 is going to be the opposite side. The adjacent side is the side next to T that is not the hypotenuse. So the hypotenuse is always across from the right angle. So the side that's not across from the right angle is the 12. So this is our adjacent side. That should be a 12. I know I cut it off. Sorry, guys. And then the hypotenuse is always the side directly across from the right angle. So that's our hypotenuse. Okay, so all we're going to do, we're going to fill in the values of the sides of the triangle that make up our ratio. So sine, we know, sine, opposite over hypotenuse. Okay, so all we're going to do is put the opposite side over the hypotenuse, which the opposite side is 8, and the hypotenuse is 15. Okay? I can't reduce this down. 8 over 15 is its most simplified version. So sine of t is going to be equal to 8 over 15. And that's it. Okay? So all we're doing is practicing setting up the ratios. We're not really solving anything right now. Okay, cosine, cosine is adjacent over hypotenuse. So cosine is adjacent over hypotenuse. Cosine of angle t, that's why the t is there. Sine of angle t, we're starting from angle t. Okay, cosine of angle t is the adjacent side, which we said was the 12, and the hypotenuse, which we said was the 15. Okay, now I can reduce down 12 over 15. Do you guys know a number that will divide into 12 and 15? Like normal, of course you do. Well, the largest number that divides into 12 and 15 is 3. So I can divide each of these by 3. 12 divided by 3 is 4, and 15 divided by 3 is 5. Okay, so the ratio for cosine of angle T is 4 over 5. And lastly, the tangent of angle T, again, this tells us the angle we start from, is tangent TOA. Tangent is opposite over adjacent. So it's the opposite side over the adjacent side. Well, the opposite side we said was 8, and the adjacent side we said was 12. And guess what? We can reduce down 8 over 12. What is the largest number that will divide into 8 and 12? Holy hot dog. That would be a 4. So I can divide each of these bad boys by a 4. 8 divided by 4 is 2. And 12 divided by 4 is 3. Okay, so the ratio of the tangent of angle T is 2 over 3. So there you go. That's example 1. We'll be doing the same thing with example 2, and we'll be starting from angle G in example 2. So get pumped up for example 2.